Assalamu alaikum everyone. Today I bring for you all a new experiment, that is experiment number 7. So our new experiment is about study the relation between volume and height of water column in a graduated cylinder. Yes, of course we will perform this experiment according to new scheme of 2022, according to the SSC examination of class 9. So let's start our new experiment, that is about graduated cylinder. In this video we will learn about how to measure the level of water in graduated cylinder. The theory behind this experiment is that what is the relation between the height or in this video we will learn about what is the relation between the height and volume of a water or any liquid in a graduated cylinder. So before starting our performance or experimentally, we will some learn about something, the relation between the graduated cylinder. Sorry, before starting our video we will learn about. So in this video we will learn about the relation between volume of a liquid or height between sorry so in this video we will learn about the relation between the volume and height. So according to the this experiment, the relation between volume and height is constant, which means that the graph between volume and height is constant. The graph of volume and height is make a straight line. So we will determine what is the relation of volume and height by the experiment. So let's move ahead. So here it is a graduated cylinder. Now you can see that you can observe that there is some printed some measurement on this graduated cylinder like this. You can observe or determine this measurement like 10, 20, 30, 40, 50, 60, 70, 80, 90, and then last 100. Right now it is an empty graduated cylinder. So before starting with this experiment we have to understand some measurement, some important things, such as this graduated cylinder is started from 10. So here we have to assume that this 10 is equal, as we have to assume that 0. So which means that this 20 becomes 10, this 30 becomes 20, this 40 becomes 30, and in this way so on. So you can also tell me in comment section what is this 100 become. Yes, I think you are right, your answer is 90. So before starting before starting the measurement and determine the relation between volume and height of water, so we have understand this major or crucial things. So right now I am going to fill this graduated cylinder with water, then we will measure its length, or we will determine the relation between the volume and height. So just wait for to fill the water. So I have filled this graduated cylinder with water. As you can observe it, if you can see the water in it, you can see that the water is shaking in this graduated cylinder in this at this point. So I have filled this water till 100 ml. So you can also observe that right now let's move. We will start to measure or determine the relation between volume and height. For the sake of measurement, we have required the scale, measurement scale, which is always in your pencil box, this one. So how will you measure the measurement with measuring scale? Like this, you will consider the centimeter scale and you will stick with this 10, like this. I hope it is clear to you all. You can also see that clearly. So you have to place this scale 0 with this 10 measurement. So if you place this 0 with 10 measurement, you will observe that your reading, like on 0 scale, your reading will be on graduated cylinder is 0. Why is it 0? Because we have considered this 10 is 0. So your first reading will be at 0. Your water level will be 0. So I hope you will understand my point, what I am trying to say, you trying to make you understand. So your first reading will be, which means volume of water is at 0, the height will be 0. So what will you have observed? What you have observed at at the volume of water at 0, the height is 0. Okay. So at this point you can write over here 0, because we have determined at 0, which is here 10, but we have assumed this 10 as 0, and the water level or volume of water is 0, so the height is also 0. So let's move ahead to, for the sake of determine second reading, or our second reading will be considered on 10. Why I called this 20 10? Because we assume that this 10 is 0, which means that this 20 becomes 10. So our next reading will be on 10. So the volume of water will be 10. So on, we have to determine our second reading at the volume of water, which is on 10. So we have to determine the height of water at the volume of 10. So let's move ahead. So this is our graduated cylinder, same graduated cylinder, and again I have put or set my scale at 0. Our first reading is 0 in centimeter. So what is our second reading? This is 0.5, this is 1, and after 1, 1.1, 1.2, 1.3, 1.4 and 1.5. You can observe it again, you can check it again, you can verify it again. Our 0 is coinciding with this line. After 0, you can read your reading like this. This is 0. The second one, big line, is 0.5. After 0.5, the second big line is 1. After that, 1.1, 1.2, 1.3, 1.4, then 1.5. So our second reading at the volume of, which is 10, you can observe it like this. This is 10, and what we have observed, our second reading, we have observed our second reading is 1.5. So our second reading is 1.5. Okay, I hope it is clear to you. So our, in this way, what will be our next volume of water is, that is 20. On graduated cylinder, what is the measurement written on it? There will be 30, but we have considered it 20. Okay, I hope you are not confusing here. So let's move to measure our third reading or taking our third reading. So I am putting this book at a side and bring for you a graduated cylinder in front of you. So here it is, our graduated cylinder. Again I have set my scale at 0. Okay, so this is 0, this is 1.5, then on 30 this is before 30, this is 3. Okay, 3, 3.1 and 3.2. So our third reading is 3.2. Our third reading at 20, at the volume of 20, our third reading is 3.2. Is 3. At 20 volume of water is our third reading is 3.2. What we have measured, 3.2. I hope this is clear to you all. Our second last reading is 30. So what is written on the graduated cylinder? There must be written 40, but we have considered it 30 because we have started from 10. The graduated cylinder is started from 10, therefore we have considered this 40 as 30. So again I have set my scale with this 0. Okay, so I am going to read our fourth reading. This is 0, this is 10, this is 20, and this one is 30. So my fourth reading is what? This is 4, 4.1, 4.2, 4.3, 4.4. This one is 4.5. So our fourth reading is 4.5. So what is our fourth reading is? So let's take our fourth reading. This is 0, this is 1, this is 2, this is 3, and this is 4. So at our fourth reading is, how we can read? This is 0 because this is not 0. This 0 is set with 10, which we have assumed that this is 0. So this is 0, 10, 20, 30, 40. This is our fourth reading. So it is this 6 is coincide with this 50, and we have assumed that this 50 is 40. So at 40 our fourth reading is 6. So we will note in our practical book or practical journal 6. The volume at 40, the volume of water at 40, what we have note the height, we note the height is 60. 6. We note the height 6. Last reading is on 40, volume of water is 6.0. So I hope this is also clear to all. We have taken all 5 reading which is required. So now we have to take the ratio of volume of water and height of water. So we will look ahead. So now we are going to take the ratio between volume of water and the height of water. The ratio of volume of water on 0 and the height of water will be also 0. So anything which you have the 0 and in numerator, the answer will be 0. So in our case both thing is 0. So therefore if you divide anything with 0, your answer will be 0. Now we have to divide 10 by 1.5. So let's take the ratio of volume 10 and divide by 1.5 the height of water. So answer will be 6.6. You can take one decimal place after decimal. Okay, so our second reading is 20. The volume of water is 20 and the height of water is 3.2. So let's take the ratio 20 divided by 3.2. The answer will be 6.25. You can also observe that what you can observe, our answer will be constant. So you can observe also here that the first reading or first ratio is 0. After that the whole ratio is coming in the range of 6. So these last two answer will be also in the range of 6. In this way we can verify that the relation between volume and height is constant. So let's see what is the ratio of 30 and 4.5. So the ratio of 30 divided by 4.5, the answer will be 6.6. okay, you can observe that here the as I in starting video I have said that the relation between volume and height will be the constant relation. They both have constant relation. If you increase one thing, let's suppose you have increased the volume of water, the height will be increased. If you decrease the height of water in some way, like you can decrease the height of water in by the help of decreasing the height of graduated cylinder, so the volume of water is also decreased, which means that they have the direct relation. If you increase one thing, the other thing will be also increase. If you decrease one thing between volume and height, the other product or the other option is also decrease. So in this way you can verify that the answer will be constant. So the ratio of last reading is 40 divided by 6.0 will be 40 divided by 6.0 will be 6.66. You can observe that our whole reading is come in the range of 6. So we will now draw the graph. We can draw the graph which shows that the relation between volume and height is constant. So let's move from on the graph. So here we are going to make a graph to verify or showing that which we have determined our reading is making the constant relation between the volume of water and the volume of water and the height of water. So let's make a graph to verify that either our reading is follow this relation or not. So our first reading at volume of water is 0, so the height of water is also 0. So at on x-axis we will take volume in ml, whereas on y-axis we will consider height on y-axis in centimeter. So how we will marking on this graph? This point is starting point we will consider here 0. okay, this 10 boxes are one big box, or you can say that 10 small boxes is equal to 10 ml. okay, these one big box or 10 now look at here how we will you mark in graph. This joining point you will consider 0. okay, this joining point you will consider for both on x-axis or y-axis. For both these joining point is you will consider 0. Now you on x-axis you can say that one big box equal to 10 ml. okay, and you can say that 10 small boxes is equal to 10 ml, which means that one small box is equal to 1 ml, whereas two small boxes is equal to 2 ml. In this way, one big box is equal to 10 ml. So if we follow this sequence, which means that one big box after 10 ml is equal to 20 ml. Okay, so in this way, after 20, one big box is equal to 30 and last box is equal to 40. Just because our volume is starting from 0 ml to 40 ml, therefore we will take here from 0 to 40 ml. Okay, let's work from for height. So this is 0, for also consider for height. Okay, so now here one big box is equal to 1 centimeter height of water. Okay, I think or I hope you will consider or understand my point, what I am trying to make you understand. Okay, so after 1, the second big box is equal to 2 centimeter. Okay, you have to follow this reading. Okay, so our reading is starting height of water is 0, after 0 1.5, 3, 4 and 6. So we have to start from 0 to 6. We have to start from 0 and we have to end at 6. So we will mark accordingly. So this is 0, this is 1, this is 2, this is 3. Okay, I hope it is visualized for to you. This is 3. Okay, after 3, the 4 centimeter, 5 centimeter and last 6 centimeter. Okay, I hope this is clear to you. Right, now move ahead and we will plot a point between volume of water and height of water. So our first point is 0, which is volume of water. At 0 volume of water, our height is 0. So where we will plot a point here, at 0 volume of water, the height of water is also 0. So we will plot a point here. Okay, now next point, our second reading at 10 ml, the height of water is 1.5. So at 10 ml, our height of water is 1.5. Now here is 1. You can see that this is the height of water, which represent 1 centimeter height of water. So from here we will count 1.5. This is 1, 1.1, 1.2, 1.3, 1.4, 1.5. Here there is a 10 or and then here this is 1.5. So I will mark my point 1.5 here in the sequence of 10, in the line of 10. So here is my second point. After 0, my volume of water is 10 ml. So height of water at 10 ml is 1.5. Now let's come on 20 ml of water. For 20 ml of water, my height of water is 3.2. So therefore I will point or plot my point in the sequence or in the line of 20, 3.2. So here is 20 and this is 2. There is 3, 3.1, 3.2. For sequence of graph or for accuracy of graph, we will consider this 3.2 to 3 because it is not converting. If if it is 3.6 or 7, so I will round off it, but here is 3.2, so I will consider here for the sake of sequence or for the accuracy I will consider 3.2 to 3. So I am considering 3.2 to 3. So this is 3. Now for the fourth reading or volume of water is 30. So at 30 volume of water, my height of water is 4.5 in a graduated cylinder. So for the sake of 30 volume of water, I will mark 4.2. Why I will mark 4.2? Sorry, 4.5, because at 30 volume of water, the height of water is 4.5. So I will mark at 30 volume of water in the height length in the sequence of 30 volume of water, I will mark 4.5. There is 4. From now I will count in the sequence. So 4, 4.1, 4.2, 4.3, 4.4 and 4.5. So I will plot my 4.5 here. Last point. For the last point, what is our volume of water? The volume of water is 40. So the height of water at 40 ml of water is 6. So I will mark in the sequence of 40. In the sequence of 40, the 6 is here. So I will plot my point is here. So now I will join this point together and show that and find or determine the relation between the volume of water and the height of water. In this way we can determine that either our reading is making a constant relation or not. So you can observe that our line is making a straight line and all points join together, which shows that the relation between the volume of water and the height of water makes a constant relation, because this straight line or this constant line shows that if you increase the volume of water, the height of water is also increased, or vice versa. You can also say that if you increase the height of graduated cylinder, so the volume of water is also increased. Why? Because there is a capacity to pour more water in it. So in this way you can say that if you increase the volume of water, the height of water is also increases. Or you can also say that if you increase the height of water, which means that the volume of water will be increased. So the line, it shows this thing. Okay, I hope you all are clear. Now one more thing is left here. You can see that the scale on x-axis, one small box is representing here 1 ml. So you can note down here, on x-axis one small square equal to 1 ml. Okay, whereas on y-axis one small boxes or one small square is equal to 0.1. okay, 0.1 centimeter. How you can count over here? This is 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9 and last 1, which means that one small box or one small square is representing 0.1 centimeter. So you must have to write this scale on graph, otherwise the checker or examiner will be confused and can detect your marks just because can deduct 1 mark for this. So you have to write, otherwise your marks will be deducted. So after this we have perform or complete our experiment. So we will summarize. I am going to summarize for you the whole experiment what we have done yet. So our object was that we have to determine the relation between volume and height of a water in a graduated cylinder. What was our apparatus? Our apparatus is graduated cylinder or scale, and one more thing is water and or right scale. So the theory was not, the theory you have not copied in your registers or practical journal. So mathematically formula is we have performed in observation table, so you don't have to write mathematically of this work or graduated cylinder heading, volume heading, but you must have to write the formula. The formula is V is equal to pi r square h, whereas we don't use this formula in whole experiment, but you have to write. And you don't need to write method in your practical journal, but on leaf page or blank page you have to draw this table in the same manner which I have told you. Okay, after that you have to draw the graph. As I told you, as I make you understand, you have to draw the graph in the graph paper. Okay, and after that you have to draw this figure, okay, in the blank page. In last you have to note this result. Okay, you can say that by the determination of all observation, we have found that the relation between volume of water and the height of water makes a constant relation or make a constant graph. Okay, in this way we have done our experiment and we have performed or our experiment. In description portion I will provide all important things regarding this experiment, like viva voice or any other important things. If I understand this is important for you, so I will provide you to at the description. So till then, Allah Hafiz. Please do like, subscribe and share my channel. So Allah Hafiz.